Hello everyone and welcome to Rebelway. My name is Andrew Sutherland and today we're going to be taking a look at the smoke and particle dust trail. And this technique can be used for all kinds of effects really. A lot of magic effects is done by particles being advected through a smoke simulation. You could do it multiple ways, but as someone who likes pyro, this is how I tend to do a lot of my magical effects, is through a smoke advection. And that just means that, you're going to get some nice interaction between the particles because the particles are following the velocity. If you ran just a simple pop sim, particles can sometimes feel a bit unnatural, but when you run a smoke sim or a flip simulation and then advect the particles through the volume of that, in this case we're advecting these particles with the velocity of the smoke, and you just get a far more natural looking simulation. It feels very tied together and it's almost like each particle is aware of each other. So we're going to be looking at that particle advection. If you also notice, this car is traveling quite a distance, and we're not culling the particles or the smoke based on the camera. The simulation is actually wedged out over 4 or 5 different wedges. The other thing that we're going to take note is if you notice when this car becomes airborne and then it impacts, that impact then results in a lot more particles and smoke being emitted, like you would imagine that the case to be. Just there's more force, more of the wheels going into the ground, so you're going to get more smoke and particles. The other thing is that we also have the particles sort of shooting out either side of the car. So we're going to take a look at how that's controlled, and that's basically just looking at the overall direction of the car and the direction of the front of the car, computing the difference between that, so you can almost see how the car is drifting and how that's going to affect the emission. And I'm sure there's a few more other things in here that I haven't mentioned, but we'll jump into the final project and take a look at how everything was set up. So diving into this final project that was created by the artist Bruno Merli, we can take a look at how it was created. So we have 3 things here. We have a car animation, which we'll share a low-res version of, and we have our height fields. And in our height fields, we just have a low-res version. This is what we're going to use for simulation, and this is our high res. And obviously we want to use our low res just because we were only really using it as a bit of collisions for the particles and the smoke, and there's no need for high res for that. So it's obviously going to be much faster if we sim with the low res, so that's what we're going to do. And like I mentioned, the effects are all wedged out. So I'm just going to briefly show you how to cache this efficiently. Here we're reading in the final sims. And if you can see, this is a very big simulation. You're traveling across quite a large terrain. So let's maybe show the car for some context. Let's enable our car. Let's turn off our terrain. So you can see we've got quite a large simulation here, and in order to cache this without a crash, we're actually wedging out the simulation, which I'll explain in a bit more detail, but I'm sure you guys want to cache the scene efficiently, so I'm just going to explain this quickly because there is a bit of a gotcha. So first of all, this is our car, and we're splitting the wheels and the tires, but what we need to do is we need to cache this. So this is our first cache, which is our vehicle, and which is just our terrain here. So this, we'll take a look at that. This is an SDF version, so like a volume version, and this is our car and terrain geometry. As you can see, we're only choosing a selection here for the collisions, as this is where most of the camera is going to be placed, and just having collisions in that gigantic scene is gonna cause a problem. So first up, we've got the source over here, and there's no need for wedging this because this is quite light, so you just cache that to disk. You can come over to this one, the same thing, because we're basically running the simulation twice. We're going to have a spiky version and a more traditional smoke simulation, and then we're just merging them together. So these are our source points, but when it comes to the actual smoke, that's when things need to be wedged out. So we're using this labs file cache, and as you can see, this looks a little bit different to what you're probably used to. And it's important that before you cache, you come over to this generate static and you press this, and as you can see now, it's going to generate these different wedges. So we've got 1, 2, 3, 4, 5 different wedges. And this wedge count is being driven by a for each point, which we'll take a look at just now. And as you can see, this is resolving on, yes, we've got 5 wedges, and this is going to go from 0 to 4. So that again is also 5 wedges, and we have this wedge attribute, and we can use this wedge attribute to drive some things like, for instance, this blast. So this blast is deleting the first one. If we were to come over here and change this, you'll see now we're on the second wedge. So this is going to change the third. So this is the third wedge. Even though it says 2, you have to count the 0. So 0, 1, and 2, that's 3 wedges. And as this progresses through this wedging setup, it's going to change this blast. And if we take a look at that, you can see, so here we have all our points, and here we're blasting everything but the 4th. So we have to come towards the end, and you can see here they turn on for the last part of the simulation. So this is our 5th wedge. And as you can see, that reflects here. If we come over to the first one, now it's going to be here. So click generate static, and then make sure you say save in background, because under the hood, this is a TOPS network, and it's important. It's not going to work if you just click save to disk. You need to click save to background. So just a bit of a gotcha there. So, and then once you've got this cached, you can move over to the smoke simulation. Same thing, generate static, and save in background. And honestly, this can be a little bit buggy at times. So once I share this file, it's probably going to show up like this. And as you can see, yeah, now it is working. But sometimes when you cache this to disk and you first load this in, it's only going to show the first cache. So something like this. And I can't simulate, it seems to be loading in everything this time. But trust me when I say sometimes you do get an issue where it only loads in one of the wedges. So you need to say wedge to merge, and then it should load in all your wedges. So just a bit of a gotcha with this file. Toggle this on and off, make sure that you are reading in your simulation properly. So that is for our first smoke simulation, and then we have our particle simulation, and you guess it, it's the exact same thing. You come over, generate static, save in background. That's our first simulation, and then we've also got this second one, which is the same thing, it's just different emission. So this one is a bit more spiky. This one looks quite cool. Let's take a look at this one. Let's change our camera view. So you can see we've got some sort of spiky dirt looking, and you can see where you got these big impacts. This is obviously where our car is hitting the ground. So we've got a multiplier that's going to multiply the velocities in these sections. So boom and boom. And so injecting that velocity from the car into our emission is going to give us this really nice dynamic simulation. And yeah, I might even try rendering these and adding it to our simulation. See how it looks in the render. But for now, I'm just using this to source our smoke, and then do a particle advection through this. So yeah, we've got this cached, same thing, generate static, save to disk, and then the last one here, generate static, save to disk. And is that last? No, we got the particle advection. Generate static, save to disk. Cool. So that is how you cache to disk. And now let's just take a look at how this was actually all created. Okay, so let's go over the overall scene now. So first things first, we need to prepare our collisions. So here we have our car. So we're just reading this in from that merge. And we're using the split to split the wheels on this side and the vehicle on the other. Then we're unpacking these. We're blasting everything except for just the tires. And then we're going to loop over this and polyfill this. So you can see that this is now watertight, and we're just looping over each one of these and using this polyfill to close all the gaps. And this is now a watertight mesh. We're converting it to polygons. We're putting down a clean, so we can just, delete all these attributes. We're using a facet to post compute the normals. Then we're going to peak this just to make it a little bit larger so it intersects with the ground. Again, computing the normals, and then we're going to compute the velocity using this compute velocity from deformation. So if we take a look at those velocities, you can see that the velocities are traveling in the direction of our vehicle, and from there we can just put this out to it with a null. On the other side, we're doing a similar thing, blasting everything except for the shell of our car. Again, converting, faceting. Here we just, we're going to use this to close up some of these gaps and make sure that this again is a watertight mesh and it's got some thickness to it with this output back. From there, we can just peak this again. Point velocity, same thing. It's traveling in the direction of the car and out. And here we're going to put a color onto the car and we make it red. That way we can use this attribute transfer. This is a trick I use all the time. Super useful. And what we can do is we can just isolate the car on our environment. So on our environment, we just read in our low res mesh and we're going to set the color to black, as you see here. And then using this attribute transfer, we can transfer that red color onto our terrain. And using this distance threshold here, we can say how much. So you can almost see the shape of the car there. And this, with this set to 10, we have, a nice little bit of environment. If we template our car, we can see. So we're going to basically use this to delete all of this and keep just the section where the car is interacting with our environment. So from there, we can say delete. We can extrude this. So now it's got some depth. And as you can see, this is like a sort of blue, purple, navy color, whatever you want to call it. And that's because the normals are reversed. So putting down a reverse node, we can make sure that our polygons are facing the correct way. And here we're just deleting that color. And here we're setting a velocity based on the normal. So this velocity is orientating with each of these polygons. We can save that out to disk, and that is our terrain. Next up, we're going to prepare our collisions. And for our collisions, we need an SDF version, so a signed distance field, which is just basically like a volume representation of our vehicle. And so what we're going to use is this VDB from polygons, and here's our voxel scale, and we're going to set this to collision, and we've also got a point velocity. So we've got velocity. As you can see, it's like doubled up a bit here. That's our velocity, and an SDF that we've renamed from surface to collision. We're going to do the same for our car, and we're going to do the same for our terrain. We're using this split to look at the collision and the other one to look at our velocity. And so we're going to merge all our, this has merged all our velocities together using this combine. And here we can merge just our collision. So this is our collision, and this is our velocity. Merge those all back together, and then we can pyro process this. We're resampling this velocity to just, and the collision val, just to make sure that this is a bit lighter. So this is like a multiplier. So 1 is going to be the original voxel scale. This is going to be half. 3 is going to be 3 times, and so forth. And we're also computing the min-max and converting to VDB, saving this to disk, and that's just going to save us some disk space. So if we take a look here, we can see our collision val, and it's quite a small, it's quite low res. And if we were to untick this, you can see that's doubled. Cool. So we're just going to save this to disk, and so this is our collision val, and then we're going to import our geometry here. Let's untick our velocities. We've got the wheels, we've got the rest of the car and our terrain. Merge those all together and save this as our geometry. So if we take a look at sourcing our points, we can take a look at, we've got our tires here. So here we're looping over each one of these wheels, and we've got this expression on here just so that we can transform this around the centroid. So it's going to get bigger and smaller and translate from the centroid of our wheel. So we've just got this made a little bit smaller, and we're going to loop that over each one of our tires, and from there we're going to scatter points. Here we're going to just take a look. We're freeze framing it on the first frame, so pressing F on my keyboard I can jump back to the first frame, and you can see this is where our, this is now frozen, and here this is kind of like a point deform, and we're moving those static points onto our wheels again. So it's now going to move with our simulation. Here we're computing the velocity. Here we've got our environment. Here we've got our points, and we're using this to create a distance. So with this point intersect distance, this is going to give us a distance, and we can use this node using that distance to delete anything above 0.5. And this is going to give us our points a certain distance from the ground. We can save that off to disk then, and out, so we can read this into our simulation. So moving over to this section here, we've got some interesting stuff for this spiky source. So here we're reading in our terrain, cleaning it up, deleting the attributes, creating a group for this top part using this upward normal, and then you can just change this to select all the top faces like that, and delete everything that isn't this top part. From there we can scatter points on the top. Here we're reading in those points, and we're transferring the velocity. And we're transferring the velocity from these points. So if we take a look at that there, and then here we can use this to delete anything with no velocity. So these are just our points with velocity, and we can use this to change the direction of our velocity. So we'll take a look at that part now. So let's actually come over here. So here we've got our vehicle, cleaning it. So just deleting everything but our normals. So here what we're doing is that we've got our tire, and we've got our suspension. And when the suspension and our tire are close together, we would expect to see a large impact. So let's just view these two together, and let's view our car. And let's look for some sort of big impact. And you can see, as you would expect, that here's quite a big impact, because these two, the distance between these two is a small amount. So basically we're just using this to check, because here we're just creating a point. We're deleting all geometry but keeping points. This is going to give us the centroid of our tire, and this is going to give us the centroid of our suspension. And here we're using this to check the distance between this point and this point. And so this is going to give us an attribute called impact, as we see here. And if we take a look at this, so whenever there's an impact, we're going to get this dot is going to turn red. And we can basically just use this to transfer this attribute here. So now you can see we've got an impact there, and these points are turning red, right? So what we can do is we're going to create this multiplier here, and we're going to multiply our velocity every time we have this impact. So every time we have an impact, our velocity is going to increase by 2. And once we pass this into a simulation, the more velocity we have, the more smoke we have, the more particles we're going to have. So this is just, it's quite a intelligent way of doing things. It's pretty cool. So yeah, this is going to be, and if you want, this is set to 2 times. If you increase this, you're going to get 4 times, you know, whatever you want. But these are the settings that we went with for now. We also have this attribute called turn. And here what we're doing, again, we're isolating our car. Let me just change the background back to that. And here we have the front of our car. So we have that and that. And once again, we're using this add to give us the centroid. And that way we can take a look at these 2 points. So here we're trailing this point, and we're trailing this point. Let's just put a merge here so we can look at both of them. And because we want to view this line throughout our entire simulation, let's come to our last frame, and we've trailed this, so now we can see the path of our entire car. And here we're going to create a line, and here we're going to create a line, and then we're going to compute the tangent and store that in the normal. So if we were to now click on this normal, we can see we've computed this tangent, and the same for this. Let me just change the color of this because this is a bit dark, a bit difficult to see. But basically, okay, so now I've transferred this tangent onto the centroid of our car, and here we're going to do the same for the centroid of the front of the car. So what we're going to then do is compare the sort of directions of these two tangents, and then that's going to show us how much this car is drifting. So here we're just zeroing out that upward direction, because we're not interested in any ups and downs the car is doing. We only want to know the forward and the sideways direction of the car. So here again, we're just zeroing that out, and then we're going to. So here we're comparing those two directions. We've got a note chat to say that this is checking between these two vectors and returns how much compensation the car is doing after the wheel steering. So basically, it's returning whether the car is drifting or not. So if these are aligned, you know, there's no drifting. But if these are vastly different, then we're going to be drifting. And this is our direction, because the front of the car is where we're always going to be going. So that's going to be stored as direction. And then we're also going to transfer this direction to this. And here we're going to check the difference between the direction and this vector here. So this is going to give us this attribute called turn, which is and here we can use this as a multiplier. So here we're increasing this turn vector up by 10. So here we're creating an attribute called difference, and that's based on, you know, what is the difference between the normal and the direction. And then if that direction is greater than this value here, then give us the turn attribute, and then we're multiplying that up by here. So if we take a look at our geometry spreadsheet, here we have this turn attribute, and you can see that this multiplier is just, you know, increasing this by 100 here. So we now have this turn attribute on that point, and as you would suspect, we're going to transfer that onto our vehicle. So pressing F. So coming back over here, we can see we're going to transfer that turn attribute onto our wheels here. As you can see, we're now transferring that attribute onto our wheels here. So in this VOP, you can see that we're using this turn velocity, and we're adding that to our current velocity. So when there's more drifting, it's going to shoot our particles out to either side. So let's just take a look at that. And you see we've got our velocity, and we're just going to add this turn. Let's delete this because we're not using this. And here what we're doing is we're adding this turn attribute to our velocity. Our velocity is a vector, so we need to convert this from vector to float. And we're just going to add this here and modify it, and then export it back out as a vector. So the float to vector, and then out as velocity. Cool. And then we can save this out to disk. Just have these points. Come over here. Okay, so let's move on to this clustering part and the spiky bit. So this is what we're going to end up with. If we come over here and let's make our background dark quickly. So here we can see it's almost like the sand sort of spraying out in this nice spiky motion. And you might actually want to even include this in your final render. I'm going to try that, see how that looks. But yeah, this is pretty cool. And before we do this, we're going to set up our clustering system. So we're importing those points that we just prepared, and what we're going to do is we're going to pack them so that we have so we have a centroid here. And then we've got this emit, and we've got a $frame here, so that this is going into an attribute called emit. So if we come onto our geometry spreadsheet, we can see the emit on frame 108 is so forth. So we basically have this emit attribute, which is just storing our frame number. And from there, we're going to trail this. I'm going to trail the entire sequence. and then we're going to freeze it on the last frame, so we have our entire trail. And then what we're going to do is we're going to use this to cluster this, and this is going to be based on our position, and we have 4 clusters. So let's just see if we can visualize this quick. And so these points have now been clustered. If we come over here, we can see these clusters: 1, 0, 1, 2, 3, and 4. So 5 clusters. And if we were to put down a color, we can see our clusters here. And let me just try. Let's come down here rather, so we can let's trail this. Yeah, so we can see here these are our clusters: 0, 1, 2, 3, and 4. So from here, we just need to organize our clusters a bit. So if we take a look here, we have our points. Here we're extracting the centroid, so it's the centroid of each wedge. And this sort button is going to arrange our clusters from the start and to the end. So here it starts at 0, 1, 2, 3, 4. Without this, you can see it's 0, 4, 3, 2, and 1. And I've just ticked on these numbers here so we can see that. Or we can come over to our geometry spreadsheet and take a look at this. So this is starting at 0, and you can see this starts at 100, but we would expect this wedge number 2 or wedge 1 to be this one. And it's currently not, the clusters are in order based on our scene, but the emission is incorrect. So that's where this comes in, and we just hit P, and you can see this is based on the frame number, and so this is now in the correct order. So if I go this again, we can see 0 is the lowest number, then 1, the one up from that, 2, and so it's going to cluster here, then here, then here, then here, then here. So this is how that is happening. So this is for each point, and it's working with this name attribute that we promoted here. So this cluster. So this is going to run over each cluster, and we've got this metadata. So if you come over here and you click this is going to create this node over here. So on this wrangle, you can see that we've got the spare input, and that's coming over here, and you can click add spare input, and that's going to give us this, and then we just drag this into here. And then on here we're creating a class, and this is grabbing the number of iterations. And as you can see here, we've got five clusters, so it's going to iterate 5 times, and that means that we're going to have the cluster 5 times. Cool. So now that we have this, we can transfer this onto our. So here we're transferring the cluster and class onto our points, and if we trail these, and we can then take a look at our clusters. So 1, 2, 3, 4, and 5. From there, we're going to transfer the velocity. So now we have the velocity on our points here, and then we're just going to use this to delete everything but the velocity, the position, the class, and the cluster. And this blast node is, I showed this before, going to delete our wedges based on this here. So we first need to say generate static, and if we click on one of these, we're going to see that it's going to delete everything but this first wedge. So if we come over to the beginning of our simulation, click F on our keyboard, and we can see that we have our first wedge. Let's change our, let's keep it on dark. So here's our first wedge, and as the second one starts, they get deleted. But if I were to swap over, you can see now our second one starts, ends, third, and fourth, and fifth. You get the idea. So this is how this cluster is being used here. So we're using that attribute. Well, we're deleting the edge based on the wedge number, and that wedge number is coming from here. Cool. So now we're going to actually let's actually just disable this, and we could actually just disable this and run this, because this particle simulation is not too heavy. It's going to get heavier once we go to the smoke, of course. So for now, I'm just going to disable this so we don't have to jump between the wedges, and let's just take a look. So we've got our points moving. I'm just going to hide this, delete these for now, and I'm going to hide my lights. Diving back inside, and we can see this is our sourcing points. So from there, we're going to feed our points into a pop simulation. And this is just a simple pop solver. We're reading in our first context geometry, and we're reading this in twice. So both of these are reading in our first context geometry. As you can see here, the birth rate is just set slightly differently. Our attributes are the same. So if you want, we can just take a look at one of these. Let's just put down the file cache quickly. We can call this test. And I'm just going to and let's just cache out 50 frames at first, and let's cache the disk. And let's just come back up here, enable this, and make sure that we have this on our first wedge. So let's just cache out the first wedge. Cool, so I've just run this section and this section. So this is the first one and this is the second one. And I just wanted to see these separately so you get a better idea of what they actually are doing. And just to confirm that the only thing that's different is the pop replicate. So here we have more, here we have less. Here we have a pop force. We compare these. Not a huge difference, just a little bit of variation. And here we have a bigger difference. And if we were to compare these two, this is the first one. You can see this is more spiky. And this one is a bit, sort of chunkier. And if we were to merge these all together, you get a combination of the both. And this just kind of looks a bit more organic. You can kind of... So here we're applying our gravity. We've got a bit of pop drag. This just adds some air resistance, makes things look a bit more realistic. Whenever I do a pop sim, I always add a little bit of air resistance. We have our pop source. We have our pop object. No bounce, no friction, also the standard stuff. Our pop solver. Here we're reading in our terrain from here. So this is going to be our collisions. I think this, we're actually using the high res in this case. here. So we've got the high res going in there. We've got the height fields. And we've got our car as the static object. And we've got our car being read in as deforming geometry and a bit of bounce on that. And those are our settings. And then out. So once we cache that, we have this pretty cool spiky simulation. Cool. From there, we're going to create a density attribute based on these points. And you can see this is just turned up here. This is just so we don't have any negative, or we don't have a density of 0. Everything's going to have a density. It's just that some are going to be lower and some are going to be higher. If we take a look here, and this is based on the age, I believe. So let's just take a look. We say RAM from attributes, and we can say age. I like to make this blue and this red. So that's our age. And if we look at our density, we're still looking at age. Let's change this to density. So you can see it's negated. If we come here, we can see this is negated, and it's got some ramp here. Then we also got some P scale. Just setting the P scale. And I'm not so sure about this, removing these points actually. I'm not sure why that was done, but that's in the original file. It seems to be, let me just see what happens when I do this. Yeah, it's not really doing much. It's just removing, I don't know. It doesn't seem to be doing anything, so don't worry about that. From here, we're randomizing the P scale a bit between 0.5 and 1. So this is like a multiplier. We're adding some noise to the temperature. So if we take a look here, we can see this is our temperature. It's just being noised up. Well, we're adding actually a temperature, and it's noisy using this. So we're adding this. See, so that is our settings for our temperature, and then we're rasterizing those attributes. We're rasterizing the temperature, density, and velocity. Our post process, so we can convert to 16-bit floats. We resampling the velocity, so this is going to be save us some disk space. Just means because we don't see velocity, so we might as well resample it, compute the min and max, and then out, so that we can run this into our simulation. And on the other side, we have basically the same thing. It's just without that spiky sort of stuff, and without the let's have a look. Let's just take a look at this one. Yeah, so it's just these sort of particles like this. So if we take a look here, it's the same idea. And if we jump inside here, just a bit more of a simple pop sim. We've got some pop force as we did before, some more pop force, some wind on this, some pop drag, gravity, and out. So this is just a bit more of a traditional looking pop sim. Deleting those attributes, and you can just see that this is sort of kicking up some dirt like that. We do have these gaps in here. That's, you know, if you wanted to get rid of that, you could just increase your sub steps. But in this case, it would look cool. And, you know, sometimes actually tires do this. As the tire turns, it sort of does have a bit of a breakup. Here we're seeing the P scale, the density, randomizing the P scale, adding temperature just like before, and out. So those are our sources for our smoke, and then we can run our smoke simulation. So now that we have our sources already, we're going to take a look at the next step, which is the pyro simulation. So on this one here, you can see this is our sim. And I think when I ran this, I'm not sure that I have the collisions working correctly here, do I? Doesn't appear so. Let's just see. Template this. And yeah, my collision actually wasn't set up correctly, but I've fixed that now. So yours should look slightly better, just having the smoke collide with the environment, and I'll recache this for the final render. But these are our pyro simulation. So we're just using this pyro source at the SOP level, and the only thing we've added here is diving inside is a gas vortex confinement. So let me just turn this brain off so it doesn't calculate. And we just have a tiny bit of gas vortex confinement. Coming over to this one, it's the same thing. We just have slightly different settings. So I'm going to explain what each one of these things are, and then I'll allow you guys, I'll leave it up to you guys to just check out the file and see the difference between this one and that one. But you know, this determines our resolution of our simulation. This are our overall substeps, and yeah, we don't have any substeps, so it's just defaults of 1 here. So coming over to our sourcing, we can see we've got our density, our temperature, and our velocity, and our temperature set to pull, velocity add, and add. Our fields, we've got some dissipation, which is going to be basically like the smoke disappearing or dissolving. That comes from the dissipation. The higher dissipation, the more your smoke is going to disappear, and the lower, you know, this is quite low, we'll just see a little bit of dissipation. We've got some cooling on our temperature. It's probably not doing a huge amount. If we come over to our shape, this is our buoyancy. The buoyancy is how much the temperature rises. So you know, it's obviously not very buoyant, you can see that. Here we have some disturbance. So what disturbance is I like to think of that as the very fine detail, and the turbulence is the overall breakup of our simulation. So you know, these sort of swirls here is probably coming from the disturbance, is probably coming from the turbulence, and the fine detail we see is coming from the disturbance. And there's not a huge amount of disturbance. So if we take a look at our disturbance, we don't actually have a great deal of disturbance, just 3.3. You know, if I was doing a big explosion, I would probably use a lot more disturbance to get a lot more fine detail. And I tend to think of disturbance as like the outside detail, the detail on the surface of the smoke simulation, whereas the turbulence is like the breakup from within. So I tend to use turbulence as a broad strokes. You break up the overall shape of my simulation, and the disturbance is to add the fine detail. And this block size is kind of the scale of our detail. So this is 0.2. That's probably like, you know, 2 feet. The sort of size. In fact, you could check by putting down a box and setting this to 0.2. So that is the size of our detail. So if we compare there, and let's look at our pyro simulation. Yeah, so that sort of block there is about the size of our detail in this case. The turbulence, these are our broad strokes. We've got a swirl size of 0.9, the amount 1.2, and we also have a little bit of viscosity here, which is just gonna, you know, you could play with this to make it look like it's underwater or something like that, but in this case we've just got a bit of viscosity. Our look, we don't need to worry about that. And our advection is set to Mac McCormick. I often actually like to set this to BFCC, and this will give us more details. But in this case, this is the settings. And yeah, that's about it. We're going to cache that to disk. We're going to use this attribute delete to delete all the things we don't need and do some cleanup. Save that to disk, and then we have a pyro bake here. And we're just using the smoke. There's no need for temperature or anything like that because there's no fire in the simulation. Cool, same thing for here, just slightly different settings. I'll leave that to you guys to explore. And here we can see that we're merging those two smoke simulations together. So here we can see a bit more of a spiky one and our normal one. Next up, we're going to take a look at the particle advection. So the very last thing we need to do is our particle advection, and that takes place here. So we've got our points, we've got that our clustering that we had before, the class. This is all stuff we've done before, and here we've got that blast, which is going to separate based on the wedge. So as you know, we're going to come here, say generate static. If we come over to this first one, we can see that this blast is going to blast everything but the first one. So if we come over here, we can see our points. And this particle simulation is a pop network just like our one before, except we've got the second input. And here we're reading in our smoke simulation. So we've got our smoke. We're deleting everything but the velocity field. So now we're just keeping this val. And we're feeding that into the second input. And this is the exact same setup, pretty much. Pop simulation, pop object. We've got our terrain, we've got our collisions. We've got some pop force, which is going to add some more velocity swirling to our particles. We've got 2 of those, a bit of pop drag with some air resistance, a gravity, and the only thing that we're adding is these pop advect by volumes. And here we're reading in the second context geometry, which is that second input, and we've set this to velocity and velocity update. And we're reading in that second input twice. So first context geometry, birth rate, pretty high, life expectancy of 3, life variance of 0.8, and yeah, that's it. So we just delete all the attributes that we don't need, cache that to disk, and now we're going to have our particles. Let's just put down a particle fluid surface, and what I want to do, set this to particles and visualize the velocity. So we can check this one out, looking pretty cool. And our spiky version, let's copy this. Cool. And if we come up here, this is where we're reading in both of them, and we can merge this with our smoke. So as you can see now, our particles are inside our smoke. Pretty cool. So that's about it. So the only thing that I'm going to do is I'm going to work on this environment a bit, and all I'm going to really do is scatter some assets from Megascans, maybe some little bushes, some rocks, and I'm probably going to do that on our low res. So on our low res, I can just come over to this paint node, and I can paint where I want to do some scattering. So let's just take a look at that. Yeah, we've got this mask. So I'm masking here and painting here. And then I'm adding an attribute noise to that mask just to break things up a bit. I'm using this to visualize, and then I can scatter points. We do also have our high res geometry that has some attributes that we could use, like we've got this height, occlusion, curvature, slope. You know, we've got a few things here that we could potentially use for scattering. But for now, to keep things simple, I'm just going to scatter on here, scatter a few points. I'm reading in, I think I've got a shrub here. So shrub, I'm just transforming this down and copying this to the points. So now we've got something you know, it's if we look through our camera here, we've got those shrubs there, and I'm going to add some rocks using the exact same technique, and I'm just merging this with the high res for rendering. And yeah, this is all going to have a lot of motion blur and be blurred out. But that's it for the simulations, and hope you learned something, hope you enjoyed this, and I'll see you guys next time. Okay, bye.